My name's Katie, and I'm a high school senior from Illinois, and this is my application for the Science Ambassador Scholarship. My topic is about moment of inertia. When you think about inertia, you're probably thinking about translational inertia, which is an object's ability to resist linear motion. Inertia is similar, but it's a little bit different. It's an object's ability to resist rotational acceleration. Now think way back to one of the first physics classes you had. The first thing you probably learned is that force equals mass times acceleration. In moment of inertia, in rotational motion, we have a very similar equation. So torque, which is the force on a rotating object, is equal to moment of inertia times angular acceleration. Now, when you put two and two together, moment of inertia is the rotational counterpart of mass. Physicists, when talking about rotational motion, use moment of inertia a lot. So that means there's tons of resources available to you to figure out the moment of inertia of many shapes. And you can probably just Google it right now to figure it out, but don't, because I'm going to teach you how to solve it all by yourself. Take an example with a Ferris wheel. So we're going to assume this Ferris wheel is completely solid, so we're going to call it a disk. First, you take the base formula, moment of inertia equals the integral sum of r squared dm. And now you don't really know what dm is, so I'm going to define it for you. dm, in this case, when you're talking about a disk, is equal to 2 pi rl times rho dr. The derivative of this radius is way easier to find than the derivative of this mass. So you take moment of inertia evaluated from 0 to r, and it's r squared, and we're going to plug in this formula for dm. So 2 pi rl times rho dr. Now, you can pull out some constants. So the constants we're going to pull out is 2 pi l and rho. So when you pull it out, 2 pi l rho, evaluated from 0 to r, the integral of r cubed dr, because you have this extra r up here, that's the moment of inertia. So now it's really easy to find the integral of this. The integral of r cubed dr is just r to the 4th over 4. Now, you say, what's rho? And rho, I also define that for you as m over pi r squared times l, which is the mass over the volume of a disk. So, once you plug that back in, over pi r squared l times r to the 4th over 4, you can cancel out, so cancel out the l's, and the r squared can go to just r squared, and this can cancel out to 2. Your final moment of inertia for a Ferris wheel is mr squared divided by 2, which, if you Google it, is exactly the same as the moment of inertia of a solid disk.